Assalamualaikum warahmatullahi wabarakatuh. A very good day to all of you. This is a second video or lesson in terms of the acylation reaction. In the first video, you have seen the synthesis of aspirin, where I have shown how acylation occurs. In this video, I'm going to show you the Friedel-Crafts acylation reaction using an example of an essential drug, levodopa. So levodopa, where or when would actually you find its use in hospitals or in patients for the Parkinsonism patients who suffer from Parkinson's diseases. They lack dopamine. The real cause of this deficiency in dopamine is really not yet to be discovered. The research is still ongoing. We still don't know the exact cause of it. So how do we treat patients with Parkinsonism? That is by giving them levodopa, loads of levodopa. And levodopa is actually the precursor of dopamine, and usually it's given in grams actually to the patient. What happens is that levodopa can diffuse into the brain through the blood-brain barrier, and it turns into dopamine, and that helps in terms of supplying or providing dopamine to the patient, and helps in terms of normalizing the level of dopamine in the brain. So now let's have a look at the synthesis of levodopa, and we're going to start with levodopa. The name actually came from the L form of this drug. And what is the L form? The L form will be, you have this in front coming out of the paper, and that hydrogen at the back there. All right, so this will be in the planar form, and this is actually, you can synthesize this chiral molecule starting from the tyrosine. You can first, so we're going to do like slightly backward. So instead of me showing step by step from starting to the end, this way, I'm going to start from the bottom. So we know what we want to synthesize. We want to synthesize levodopa. So we're going to start with starting material from the bottom here. So here, I'm going to write here, we're going to start with this tyrosine. We can probably have, is going to be a two-step reaction. So what we have is, we have this. You have a very simple amino acid, CH2, CH, carboxylic acid, and you have the amino group. And here you have OH group. All right. So in the first step, what we're going to do, this is a Friedel-Crafts acylation. So you have CH3 COCl in the presence of aluminium chloride. This is called, let me put it here, is acetyl chloride. And this is called aluminum chloride. If you remember the Choose lecture about the Friedel-Crafts alkylation, you would straight away, you probably guess what you'd get at the end. In here, what we're going to do, because this is a Friedel-Crafts acylation, what would happen is that, so this will react with the ring here. All right, so what we're going to do is we're going to draw this molecule again. Like that. The entire molecule is the same, and this Friedel-Crafts acetylation is very specific to the aromatic ring. Okay, so this, what will happen is that it will add on this part of the molecule, only this part of the molecule. It's including the oxygen, the carbonyl group. Okay, it's this group, if you see, it's like, just a simple acetylation. It is, you are right if you think that it's just an acetylation. Yeah, is this adding on the acetal group? But if you compare with the first video where you have the acetylation of the OH group of the salicylic acid, the difference here is that this particular group, the acetal group, is added to a aromatic group. Yeah. So what we have here is we're gonna have carbonyl there, yeah, the acyl group, and then you have the CH3. Okay. So once we have that already, this is close. This is close to the levodopa, the end product that we want. Yeah, the drug. Okay. But what happens is that now we don't want the acetal group here. We want an OH group there. So how can we convert that acetal group on the benzene ring here to the OH group? All right. So to do that, we're going to actually add hydrogen peroxide. Okay. And sodium hydroxide. So in the presence of this reagent, what happens that it will then deacetylate. Yeah, this is a deacylation. You will remove this acetal group to form the OH group. Okay. All right. So let me just to sum up. In the synthesis of levodopa, there are many ways to synthesize levodopa. This is just one of the ways. It's quite simple. It's only 2 steps. Okay. 2 steps. All right. So first, what happens is that we're gonna actually treat this molecule, this tyrosine, with acetal chloride, and then in the presence of aluminum chloride. So this is the classic Friedel-Crafts acylation. All right. When this compound has been treated with this acetal chloride, it will add on that acetal group onto the aromatic ring. At this point, you try to compare with aspirin. The difference is that this is a carbon-carbon bond reaction, whereas in the aspirin, the acetylation is a carbon-oxygen bond reaction. Okay, so in here, what we want at the end is the OH group, the aromatic hydroxyl group. Yeah, so we treat this molecule with hydrogen peroxide and sodium hydroxide, NaOH, and that will deacetylate this molecule into our desired compound. Okay, right. So we have Friedel-Crafts acetylation. That's the first step. And the second step, we have deacylation with hydrogen peroxide to give our levodopa. All right.